Good afternoon, YouTube. Welcome back to the channel. Welcome back to another lunchtime study session. It is Tuesday, July 29th. Hope everyone is having a good day wherever you are. As you can see, today I think we'll be doing some subnetting, some good old-fashioned subnetting. Yeah, it is still a iffy subject for me, so I've only done a handful of videos on these. I try to do a little bit of study each week. I haven't been very good about it, so I want to start getting into a better rhythm focusing on these. And of course, as you can see as well, we are looking at subnettingpractice.com. I'm going to go ahead and erase my whiteboard here so that I can redraw it, because I would like to get practice with that as well. This is what I would do going into the test, provided I test at a testing center that allows you to have a whiteboard and pen or marker. So the first thing I'm going to do is I'm going to draw my little subnetting chart, and I'll show you that in a moment. So I'll start at 128 along the top, 64, 32, 16, 8, 4, 2, 1, just like that. 128, 64, 32, 16, 8, 4, 2, 1. And then along the bottom left, or the left side, I start at 128. And then basically I am adding this time instead of subtracting. So from 128 to 128 I add 64. And let's see if I can do this math quickly in my head. That's 192. And then to 192 I add 32. And that gives me 224. 16 plus 16 is 240. 248, which is plus 8. 252. 254. And 255 on the very bottom. So I end up with two rows, one along the top, one along the side, both beginning at 128. And this becomes useful for plotting, for example, to get subnet masks. It becomes useful for that. It gets useful to quickly determine the block sizes, so the number of hosts, the size of the blocks of hosts in each subnet, things like that. So as I use it, I'll kind of point things out. So we're going to start with this first one. It looks interesting. And what I like to do is try to work out an answer. I'll talk through it. If I get it wrong, then I will click this button here. I only want this type of question, and we'll kind of drill that style of question so that we can learn it and make sure we get it right on the actual exam or in real life. Actually, it's probably the better way to say that. Okay, so you have a subnetwork, 192.168.109.0/24. It is divided into, okay, so that means 256 IP addresses. All right, because it's a /24, so we have the fourth octet free. It is divided into subnet A and subnet B. Your boss wants to add a third subnet, C, with 52 hosts. Is this possible? If yes, provide the network address of the new subnet you will be adding, 192.168.2.14, as an example. If it is not possible, type no as your answer. Okay, so what is the block size or the space of subnet A? So first of all, we're working in the fourth octet. These 255s designate the first three octets as the network space, so that's not going to change. The 128 shows us that when I see that 128 here in the fourth octet, I mark it down, and technically you don't have to, because this is pretty specific and straightforward. But what it tells me is that, okay, our block size for subnet 8 is 128, meaning available hosts go from 192.168.109, not .0 because that's the network address, but .1 up to .127, and 128 is not available either because it is the All right, I should say 127 is not available because it's the broadcast address, so up to 126. All right, and then the next block starts at 128 and goes up from there. Okay, so as you can see, subnet B begins the next block, and it has a subnet mask of 192. So that's going to be the first two. So it's a /2426 subnet. And it goes up in blocks of 64. So on subnet B there, I see that the subnet mask is 255.255.255.192. And 192 I plot along the top here. And that 192, because 128 and 64 is 192, tells me the last thing that I plot, that's going to be our block size. So starting at 128 and going up 64 is the space that we have for this subnet. And then the question becomes, okay, is the remaining space available enough to fit the 52 hosts we want for subnet C? And I think the answer is going to be yes. So, okay, so first of all, let's figure out what this goes to. So it goes to, let's see, 128 plus 64 is 192. So this is going to be up to 191. Okay, so that's the space of available whatever subnet. So 128 plus 64 is 192. So subnet C will start in its fourth octet, I think at 192. All right, and so if this is possible, and so if it's at 192 and it needs to have a space of 50 for 52 hosts, well, 192 up to the end of the subnet would be up to 255. And then if we subtract those, we can see how much space is available. It's going to be 64 again, or I should say 256. So it will, there is an additional block of 64 hosts or of IP addresses available. And even if we subtract the 2 that we need for the network address and the broadcast address, we still have more than enough space for the 52 hosts. All right, so that's what I'm thinking. I'm thinking the answer is yes, and that our network address begins at 192 in the fourth octet, and everything else stays the same. So let's try that. So 192.168.109.192. Blah, 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 168.109.192. Let's submit it. And yes, the answer is correct. Sweet. All right, so let's read the little description they give. Calculate how much space subnet A and B take up. To calculate how many IP addresses a subnet takes up, look at the network mask. If in this case we are working in the last octet, okay, that's always an important thing to determine. I've realized, because so many times I've gotten the answers wrong because I didn't make the correct inference about which octet we're working with. In this case, we are working in the last octet. Subtract the net mask value of the last octet from 256 to see how many IPs each subnet mask uses. For example, subnet A uses 256 minus 128, leaving 128 IP addresses. I do it slightly differently. I just plot along my little chart here. But you could just subtract whatever is in the subnet mask for that octet from 256 and get the same answer. Do the same for subnet B to get 64 IPs, which we saw. Knowing how many IPs we have used up, we need to know how many, we need to find how many we need. We need 52. We need to find a block size minus 2, which will fit our needed hosts. The block size is how many IPs we need. In this case, we need 64 IPs. The network address for subnet C would be the first IP of the next block for the net mask of subnet B. In this case, 192.168.109.192. All right, so they basically said exactly what we did, and they arrived at the answer in some slightly different ways, but I hope I explained that adequately. All right, moving on to the next one. Okay, so summary routes. Enter the smallest summary route, which would include all of the given subnets. Please present your answer in slash notation. Okay, so we need to come up with a route, come up with a subnet that matches all of these to the greatest degree possible. What do I mean by that? Well, notice that in the first octet, they all share 192. Okay, so we know that all of them are the same in the first octet. The same with the second octet, they're all 168. The same with the third octet, they're all 221. So they've got all of the same bits across the board in the first 3 octets. So I'm just going to go ahead and write that part of the answer down. I'll do it locally here first, so I don't accidentally press something. 192.168.221. something. Okay. Now in the last octet, they've all got different values. So we want to come up with the binary for each of the values and then go left to right and go as far as we can where all 4 subnets have a bit. And then we will stop when there is a subnet that is missing a bit, or there's some differentiation between the 4 of them. So we're trying to go and capture as much space as we can where they're all similar. So let's start there. All right, so first of all, let's plot the binary for 108. And I'll do this on my chart and I'll show you in a moment. So we're not going to do, okay, it's not on 128 because that's more. So we got 64. 64 plus 32 is what? 92, right? No, 96. 96 plus 16, 106, that's too much. 96 plus 8, that's 104. 96 plus 8 is 104. Plus 4 is 108, and then the rest are zeros. Okay, so for the first top address there, you can kind of see what I did. I just plotted across the binary. So 128 is a 0, 64 is a 1, 32 is a 1, 16 is a 0, 8 is a 1, 4 is a 1, 2 is a 0, and 1 is a 0. I'm going to do that for all 4, and then we'll see where they stop being the same, and that will determine our summary route. 116, so not for 128, okay. 64 plus 32 is 96. 96 plus 16, that's 116, so that's not going to work. 96 plus 8 is 104. Is this right? Wait a minute. 64 plus 32 is 96. 96 plus 16. 6 is 12, 9, 10, 11. Oh, okay, so I was wrong. All right, so there's already a differentiation because 96 plus 16 is 112, 0, and we're trying to get to 116, right? 112, we got a 1 in the 4. All right, so let me erase my silly old math here and show you. So now I've got another octet plotted in binary, and you can see they're both the same at the under 128. They're both the same under 64. They're both the same under 32, but they're not both the same under 16. So this is basically where we're going to stop, unless after we plot the remainder of the remaining subnets, if they stop earlier. So we're going to do those real quick. So again, 128 is 0. 64, 32 is 96. 96 plus 16 is 112. All right, so I don't even need to go further because we know that makes it all the way. And the same 0, 1, 1, 96 plus 16 is 112 plus 8 is 120. So we don't even need to do the rest of these. All right, so where are they all the same? They're all the same under 128 in the first bit, or sorry, the last bit, I guess. All the same under 128, all the same under 164, all the same under 64, under 32. And the first time they're not all the same is under 16, so we're going to stop before there. And we're going to use this to create our summary space, or our summary route. All right, so now it's going to look a little, I think it's going to be tricky, but let me see if I can figure it out. So 64 and 32, I'm coming up with a value for this octet. I think it's going to be 96. And then what's the slash notation? The slash notation, it's got 3 bits consumed, meaning that's 24, 25, 26 slash 27. So we're in the 4th octet. We've added up those values to get 96 for our, the decimal value of our 4th octet. And then we added to 24 the 3 bits that were taken up by these 4 addresses, across, and that's 24 plus 3 is 27. So that's my guess, that it's going to look like this. So the first 3 octets are the same, 192.168.221.96, and we're going to do a slash 27. Here we go, submit. And that was correct. Man, that felt good. Okay, that's awesome. So let's read through it. Got the correct answer, walking through that. Let me erase all this stuff. Now the question I have is doing this, the speed at which I've done it, going to be fast enough for the CCNA? And I'm not really sure. Okay, yes, the correct answer is that. Remember to check where the bits of each address fall. Sometimes 2/24s do not fit into a single /23. Instead, one sits in 1/23 and the other sits in a following /23. For example, 192.168.1.0/24 and 192.168.2.0/24 do not fit into a single /23. The first is half of 192.168.0.0/23, and the second is half of 192.168.2.0/23. To check your calculations, feel free to use the VLSM calculator, variable length subnet mask. So I don't know, that description doesn't really help me much. I don't really see how it answers the problem where we're kind of like trying to find the most efficient summary route where all bits are shared. But basically, you go left to right and you plot out all the bits and you stop when at any point where they're not all the same. That's how you calculate the summary route. All right, let's do a few more. Next. Okay, let's see. What is the broadcast address of the network 10.32.177.222? 255.240.0.0. So the octet of note is the second octet. So the broadcast address. So first of all, we need to figure out our block size. Then we need to figure out the final address of that block to get the broadcast address. All right, so first of all, let's figure out the block size. So we are working in, let's see where we are. Let's just work on the second octet for a second here. 10.32, so 240. Okay, so I've plotted 4 across over to 16 and down to 240. And I like to use this basically when I want to figure out the block size and I'm given a subnet mask like I am here, this 240, you can just come down to 240 and like count those up. Okay, there's 4 ticks going down. Sorry. There's 4 ticks going down to 240. That means I just need to make 4 ticks across, and that tells me our block size, which is 16. 4 ticks, kind of like, and 1 starting in the corner, etc. All right, so if we know that our block size is 16, that means actually 10.32. So 16 plus 16 is 32. So 10.32 is our network space. So that's not going to change. And then we've got 2 more octets. So we're going to use, to get to the broadcast address, we're going to use all of the space and get to the last host. So all of the space in the third, I think that's going to be 255. And then all of the space in the 4th octet will be used. That's going to be up to 254, with 254 being the broadcast address, like the last available address. I think that's right. I don't think it's 255 because that would be like the beginning of the next one or like the end. I could be wrong. Let's see. I think it's 10.32.255.254. My second guess is 10.32.255.255. But let's try it. 10.32.255. So all of the third octet. Yes. .254. Submit. That is not correct. Shoot. All right, show me the answer. 10.47. What? What? I did something wrong. I didn't calculate my block size correctly. I think. 10.47, 255, 255. So first of all, I was wrong about the broadcast address being 254, so that's good to know. The broadcast address is 1 less than the next network address. Count in block sizes. The block size is either 256 minus the net mask or 2 to the 32 dash slash. I don't know what that means. Well, that's fine. Okay, what is 256 minus the mask, which is 240? 16. So I was right about the block size. What is the broadcast address of the network? 10.32.177. Okay. So 16 plus 16 is 32. I think I understand. So in the second octet, In the second octet, the range of available addresses goes from, because it's a block size of 16, goes from 32 to plus 16 is what? 32 plus 16 is 48. All right, and it's going to be one less than that to get 47. 10.47, and then using up all the remainder on the other two octets up to the 255 for a broadcast address. All right, so I got that wrong. Let's click our little button and try a couple more of that type. All right, so I only want this type of question. Next. What is the broadcast address of the network 172.16.123.41? All right, let me try my little pattern again. So 224 in the third octet. So we're concerned about the third octet. 224. So let's see. 3, 2, 3. Block sizes of 32 in the third octet. Okay. So we've got 0 to 32. 32 to 64, 64, 96, 96 to 128. So our space is 96 to 127. Okay, now, don't need this. So our space that we're using from the third octet is 96 to 127. Okay. So I think that's going to be 172.168.127.255. So it's one less than the next network address and uses up all of the remaining space to get to the last available address. 172.16.127.255. 172.16.127.255 as the broadcast address. That is correct. All right, one more just to make sure we got it. Okay, what is the broadcast address of the network 192.168.28.231? All right, it's a /27, meaning we're in the fourth octet. We're adding 3 bits to the fourth octet. So we got 24 up through the third octet, 24, 25, 26, 27, which means I just added the 3 bits to get to 27, starting at 24 for the fourth octet. Our block sizes are in 32. All right, so we need to figure out where we are in the network. So basically, well, we know we can go to 128, start at 128, because 32 is I don't know what the word is. I forgot it from remedial math, but it's a factor. I think it's a factor of 128. 32 is a factor of 128, meaning it can be divided or multiplied evenly up to 128. All right, anyway. So we go 128. I'm trying to figure out where 231 is, where it lands, in which block. I'm trying to figure out in which block of 32s does 231 land. So 128, let's see, plus 64 is 192. Okay, 192 plus 32 is 224. So we're at 224. So we're from 224 plus 32 256. Okay. So 224 to 256 is the next available thing. And I think it's going to be 255, one less. All right, I think. So we're in the we're in the fourth octet to 255. Yeah, I think we just go to the very end. Let's see if that's correct. 192.168.28.255. Because we're working in the fourth octet, we're going up in groups of 32, and the very end is 255, which encompasses the block of 32 that 231 is in. Let's see if that's correct. And that's correct. All right, so I feel pretty good about those. Let's do one more. Subnetting questions. Using the diagram below, which of the following IP addresses would be valid to assign to interface FA Fast Ethernet 03? For your answer, type out the IP address. So which of the following would be valid to assign to that? All right, so with these, we are looking at, like, what is it telling us? Like, how much space is being used up by the first subnet, the second subnet, and then we need to like start the third subnet and give F03 an IP address that falls in the third subnet after we've determined like what additional space is available. So let's just look at the other subnets first. 192.168.0.64. It's a /192. Means subnet A takes up the space 192.168.0.0 up to 192.168.0.64. Actually, no, I take that back. It starts at 64. Okay. Yes. All right. So this is actually the second in sequence. So actually, subnet B goes from 0 in the fourth octet. And if we plot 192 on our little thing here, we see that we're doing block sizes of 64. So subnet B goes from 192.168.0.0 to 192.168.0.63. Subnet A goes from, so we gave the IP address here to FA02, an IP address that falls in that range somewhere from 0 to 64, all right? The same thing for subnet A. We give it a range from 64, and it's a block size of 64, so 64, 128, 127. So somewhere, a valid IP address for F01 is somewhere within the range, in the fourth octet, within the range of between 64 and 127. So we know that 0 to 63 is all used up. 64 to 127 is all used up. And we're not moving into a different octet because we're already in the fourth octet. So that means the remaining space is from 128 to 255. So 0 to 63 is used up by subnet B. 64 to 127 is used up by subnet A, leaving 128 to the end. So now, for subnet C, we need to apply an address to F03 that makes sense. Well, that means we need to apply an address to F03 that falls in the remaining available space, which as we said is from 128 to 255. And as you can see, the answer reveals itself right here, 192.168.0.129, which falls in that space. All right, so let's do that. 192.168.0.129. And just to confirm, what did they say? Using the diagram below, which of the following IP addresses would be valid to assign to interface FO3? For your answer, type out the IP address. So 192.168.0.129. Is that correct? Yes. Submit. Yes, it's correct. All right. So see which IP fits outside the currently existing subnets. Which IP, lands in space that's available still after the other two, after you've determined what space is consumed by the previous two. Okay, I think that's enough for now. Thanks for listening. Let me know in the comments if you enjoyed this or if you want to see anything different about how I'm doing this. I like these because they're always brand new. Never see them before and can work through them in the same way we would on the test. And I like just talking through the problems. It helps me to learn actually by kind of talking through things and trying to slow down and teach you a little bit. Okay, hope everyone has a good rest of the week. Expect, for those of you who are subscribed, expect a video on some other stuff later in the week. All right, have a good day and thank you.